Okay, guys, so this is year two, level two. This is what you guys got to look for. I'll try to put it on there, year two, level two. This is the first time I talk to you guys. All your chapters are going to be from the book level two book, which will be AC theory, motor controls, uh, conductor installation, junction and pole boxes, electric lighting, cable tray, conduit bending, splices, grounding and bonding, circuit breakers and fuses, and control fundamentals. Those will be your 4 chapters, or your 12 chapters we're going to do. All right, so there's going to be 5 questions today. I'm going to review. There's 20 review questions total, so it's going to say year 2 AC theory, chapter 1, part 1. Year 2 AC theory, chapter 1, part 2, and 3 and 4, because I'll do 5 questions at a time, so you guys don't get all backed up on them, and it doesn't take too long. It'll be fairly simple. All right. So we know this is I'm gonna start right now. So we know that electric current always produces what? Whenever you send current through something, it produces what type of a field? A magnetic field. Current goes through a line, the pipe is made of metal, current is flowing in multiple directions, it creates a magnetic field. The numbers of cycles in alternating current that undergo per second is known as what? What is the cycles known as? What are they known as? What word? Amperage, frequency, voltage, or resistance? They're known as frequency, right? 50 to 60 hertz is 50 to 60 cycles per second. That's your frequency. What is the peak voltage in a circuit with an RMS of 120? Well, if we have an RMS of 120, which is the true value of your 120 volts, the peak that it might spike at, if you get out one of the big meters that show the spikes and the valleys in voltage, you would have to divide 120 by, remember the number 0.707, that was that specific number that tells your peak. So if you divided 120 by 0.707, that would give you like 169.8. So 170 volts would be where it spikes at, and then 120 is your true voltage once it's adjusted. All right. Which of the following conditions exist in a circuit with pure resistance? So when you have pure resistance in a circuit, the voltage and the current are in phase. They're running together, voltage and current. Okay. When you have when you have an inductive circuit or something like that, then the voltage will be either leading or lagging. In inductance, I think the voltage is leading the current and pulling the current along, because inductance is a created resistance within the magnetic field, where pure resistance is just the resistance of, say, the length of the wire or the size of the wire or the temperature of the wire. So that would be pure resistance, where induced resistance would be something created within the field. So the answer to that would be the voltage and the current are in phase with each other with pure resistance. And question 5 would be, in a purely resistive AC circuit, if you have 240 volts and you have 10 ohms of resistance, Ohm's law, E, which is voltage, over I times R. So draw that little pie chart. What do? If you got 240 volts and you got 10 ohms of resistance, you divide the 10 into 240, and that gives you your 24 amps. So you use the Ohm's law pie chart. Okay, so that's what I'm going to do every day. Review just like that. We're going to talk about it. I'm going to give you these 5 questions. So these questions are going to be in alphabetical order. So the answers will be A, B, C, D. Okay, so electric current always produces what? What does electric current produce? A, mutual inductance. B, magnetic field. C, capacitive reactance. D, high voltage. What does electric current produce? All right. 2, the number of cycles in alternating current that undergoes per second is known as what? What is it known as, the cycles per second that go by? Cycles per second is known as A, amperage, B, frequency, C, voltage, D, resistance. It's known as B, frequency. Okay, so cycles per second would be B, frequency, which is equal to hertz. It's how many cycles per second. So when you see 50 to 60 hertz on a motor chart, it's your cycles per second. Okay, so it's frequency. What is the peak voltage in a circuit with a true RMS of 120? Take your calculator, divide 120 by 0.707, and round up. That will give you your true voltage. And the answers are 117, B 120, C 150, D 170. Number 4. Which of the following conditions exist in a circuit of pure resistance? What happens in pure resistance? A, the voltage and current are in phase. B, the voltage and current are 90 degrees out of phase. C, the voltage and current are 120 out of phase. D, the voltage and current are 180 out of phase. So in a purely resistive circuit, what would be the condition? And number 5, your last question, Ohm's law again. In a purely resistive circuit where 240 volts is applied across 10 ohms of resistance, Ohm's law pie chart, the amperage is A 10, B 24, C 60, or D 120. So those are your questions for today. In the comment block below this video, hit subscribe and then put your numbers, your letters in, number 1 through 5, letters A, B, C, or D, and your initials, and you'll be all set for the day. Each day from Sunday to Thursday, you'll get, if you subscribe, the link will come right to your messenger. You just click on it, you'll watch the video, put the stuff in, and you're done for the day. And if you're unsure, you go back to the video and you just look it up. It's an easy 100 and get you out of there with the highest grade we can through the year. So that was the first 5 questions for this chapter. Now there's 20 review questions, so there's going to be a part 2, part 3, and part 4, and then we'll move on to motor controls. All right? Okay, guys, have a good day. We'll talk to you soon.